Hello students, let us continue with the chapter Gravitation. Expression for gravitational potential energy. This is a derivation for 3 marks or for 5 marks. Important derivation. Each and every object is pulled towards the earth. Means object is held with some energy. That energy is called gravitational potential energy. Let this be the earth, center of the earth, O, mean radius of the earth, capital R, and mass of the earth, m. Let us keep a point object of mass m at a distance r from the center. So this is r, and this r equal to radius of the earth plus height. So this is height h. Okay. So for time being, let us use r. Mean radius of the earth, mass, and universal constant of gravitation respectively. This mass m is moved by distance dr. Please understand, dr is small displacement. R is the distance. Small r is the distance of the mass from the center. So that mass is displaced, moved through dr. So direction of force applied is upward. Direction of displacement is also upward. And angle between force and displacement is 0 degree. So let us find work done. Understand the statement. It is small work done denoted by dW equal to force dot displacement, displacement is dr, equal to force dr cos, angle between force and displacement is 0, therefore cos 0. Cos 0 is 1. So F dr is dW equal to force of attraction between this point mass m and mass of the earth. Students, recall, we should consider distance from the center of the earth, to mass m. Therefore it is g mass of the earth m, mass of the object m, by distance between these two is small r square into dr. So this is small work done for small displacement dr. Work done to move from R1 to R2 is total work done. We should integrate dW equal to integration of g m by r square into dr. Limits are from R1 to R2. So you should write here R1, R2. Work done equal to GMM constants, GMM constants, integration R1 to R2, 1 by R square means R to the power of minus 2 into dr equal to GMM R to the power of minus 2. The integration goes like this: x to the power of n into dn means x to the power of n plus 1 by n plus 1. Increase the exponent by 1. Write the same exponent in the denominator. So this becomes r power minus 2 plus 1 by minus 2 plus 1. Limits are from R1 to R2 equal to GMM minus 2 plus 1 is minus 1. That minus is this minus. R to the power of minus 2 plus 1 is minus 1. So R goes to denominator. 1 by R. Limits are from R1 to R2 equal to minus minus GMM, give upper limit, write it as 1 by R2 minus give lower limit to the variable 1 by R1. So this is the expression for work done. So this work done is the potential energy. Therefore, gravitational potential let us denote it by U equal to minus GMM into 1 by R1 minus 1 by R2. Okay. Now let me continue with this equation. This is the Earth, center of the Earth. Mass m, point mass m, is brought from infinity. So R1 is at infinity, and let this be R2, position R2, and R2 be equal to R. So we are bringing small mass from infinity to this point. Now let me substitute these two, R1 equal to infinity and R2 equal to R, in the expression for potential energy. If R1 equal to infinity and R2 equal to R, then potential energy equal to minus GMM 1 by R, R2 becomes R, minus R1 becomes infinity. 1 by infinity is 0. So minus GMM by R is the expression for gravitational potential energy at point where position vector is R2, at some point where distance is R, and this R is also equal to R plus H, isn't it? minus g m m. Now what is the expression for, or what is the statement for gravitational potential energy? Gravitational potential energy is the work done in bringing a mass from infinity to that point. Gravitational potential energy at a point is the work done in bringing a point mass m from infinity to that point. Students, make sure that you write this statement. Okay, don't forget. And what is the significance of negative sign means? Negative sign indicates that it is attractive potential. Means every object is held with the force, with some energy. Negative sign indicates attractive potential. Expression for orbital velocity of a satellite. Let this be Earth, center of the Earth, mean radius of the Earth, capital R, mass of the Earth, capital M. Okay. If this is a satellite which is revolving around the Earth, for the sake of simplicity, let us take circular orbit. Okay. Satellite of mass small m at a distance or at a height h above the ground. So total distance becomes r equal to r plus h, isn't it? So let me write statements for all this. Consider us satellite of mass m revolving around the Earth at a height h above the ground. R, M and G be the mean radius, mass of the Earth and universal constant of gravitation respectively. Okay. If satellite is revolving in an orbit, then there should be centripetal force. The necessary centripetal force for the satellite is provided by gravitational force between mass and this mass, huge mass, mass of the Earth. The necessary centripetal force for the satellite is provided by the gravitational force. Therefore, centripetal force equal to gravitational force, isn't it? Students, what is the expression for centripetal force? Isn't it mv square by r, where r is radius of the circular orbit. So in this case, this is r, small r, and this r is r plus h. Okay, equal to gravitational force, capital G, constant, mass of the Earth, mass of the satellite divided by r square. And this velocity is orbital velocity VO. Okay. Here r get cancels with 1r. So the expression for V0 orbital velocity is gmm by r. Here m also get cancels, g m by r v square, therefore it should be square root. So this is the expression for orbital velocity. Observe, orbital velocity is independent of mass of the satellite. This is also equal to root of g m by r plus h. Small r is r plus h. So with the increase in h, orbital velocity decreases. So as the satellite goes away from the earth, its speed decreases. So what are the outcome of this expression? Orbital velocity or orbital speed decreases with height. Second, orbital velocity is independent of mass of the satellite. Satellite could be of this size, grams, which are called nanosatellites, or satellites can be huge, hundreds of kilograms. So for every type of satellite, orbital velocity at that height remains constant. That is this expression. Students, you have to remember this, root of gm by r plus h. This is mass of the earth. Mass of the satellite is missing. Okay. Expression for escape velocity. Escape velocity of a satellite, escape velocity of a spaceship, of an object from the gravitational pull. That is the meaning. Okay. If this is earth, center of the earth, mean radius, mass of the earth. If this is a satellite of mass m, spaceship of mass m, revolving at a height h, from the surface of the earth, or at a distance r from center of the earth, which is r plus h. It is already revolving. It is held by gravitational pull of the earth, isn't it? If this satellite is free, then it should not be under the influence of Earth's gravity. So we can throw this object, satellite, spaceship out into the outer space, out into the space, only when kinetic energy of the spaceship is equal to gravitational potential energy. So by some means we have to throw this out. So we have to give kinetic energy, and that kinetic energy should be at least equal to potential energy of the system. So let me write few statements for this. As usual, r, m and g be the mean radius of the earth, mass of the earth, and universal constant of gravitation respectively. Okay. To escape the kinetic energy should be at least equal to gravitational potential energy. Therefore, kinetic energy equal to potential energy. Which potential energy? Gravitational potential energy. Okay. And kinetic energy is half mass of the object velocity square. This velocity is escape velocity, E. Equal to gravitational potential energy magnitude G, mass of the earth, mass of the object, by distance. Distance from the center is r. So small m get cancels. Escape velocity equal to 2 to the other side, 2 g m by r under root. So this is the expression for escape velocity, equal to root of 2 g m by r is r plus h. R plus h. So this is the expression for escape velocity. Again, observe, escape velocity is independent of mass of the object, and with the increase in h, with the increase in height. Okay. Observe the equation. With the increase in height, escape velocity decreases. So these are the two observations. First one, escape velocity is independent of mass and it depends on height. Escape velocity decreases with height. Okay. In the expression for orbital velocity, it was gm by r plus h. 2 was missing, but here you can find that 2. Okay. So in this sense, we can write escape velocity is root 2 times orbital velocity. This is another observation. Always escape velocity is greater than orbital velocity. It is root 2 times orbital velocity. Expression for total energy of a satellite. Observe, if this is the Earth, at some height a satellite of mass m is revolving. This height is h. Total distance is small r, which is equal to r plus h. If this mass is revolving, then it is revolving with some velocity. So satellite has kinetic energy. And kinetic energy of the satellite is half mass of the satellite into velocity square, and this is orbital velocity. But what is the expression for orbital velocity? This is orbital velocity. Orbital velocity is root of gm by r plus h, implies kinetic energy equal to half m v orbital velocity square. That turns out to be gm by r plus h. Now let me rearrange. it is half g m by r plus h. But this satellite is also held with some energy. That energy is called potential energy. Students, you know the expression for potential energy, isn't it? Satellite is also held with energy called gravitational potential energy, and potential energy equal to minus g mass of the earth, mass of the satellite by distance. Distance is r plus h. So what is total energy of the satellite means? It is sum of kinetic and potential energy. Total energy E equal to kinetic energy plus potential energy. Kinetic energy is half g m by r plus h. Potential energy is minus g m by r plus h. So this bracket quantity is constant. So let me take this out, common factor. So it becomes g m by r plus h. Remaining is half, and in this minus 1. Half minus 1 is minus half. Remaining is g m by r plus h. Therefore total energy equal to minus g m by r plus h. This 2. This total energy is also with negative sign, means satellite has both kinetic and potential energies. Total energy is negative, implies that the satellite is held with this final energy. So negative sign indicates that this satellite is bound. Satellite is bound to Earth's gravity. First find out potential energy, first find out kinetic energy of the satellite, then get the expression for potential energy of the satellite, add these two and rearrange. You will get expression for total energy of the satellite. Okay.